Well, just getting off the stage here at the Analytics, Big Data and the Cloud Conference is Marshall Presser. And Marshall, you're with Green, Plumb, and EMC.
That's correct.
Okay. You're talking about Hadoop, a word that I had not heard before I came here this week. And even when I Wikipedia'd it, I don't know, that's probably, you could probably say it better than that. But this is a relatively new application.
It's a new technology for analyzing data. Let's say it's new in terms of its popular acceptance of a few years, but it began as a project in Google and then adopted by Yahoo 7 years ago, or in the early 2000s, as a way of dealing with masses of data that they get from, among other things, all the web clicks that you've gone through, where you're going through, how to index the internet in a way that they can do it in a quick fashion, sense of Google. And the existing tools at the time weren't right. Relational databases, traditional SQL databases that you get from Oracle and IBM DB2 and SQL Server, just were not up to the task, and also not up to the task at the cost that would entail to organize that much data.
So if they kept doing it the old way, the cost would be prohibitive?
The cost would be prohibitive, and eventually they couldn't do it. It just wouldn't scale. It wouldn't be performant enough. So they invented this new technology. And they're smart guys there. You know, they are really smart men and women there. So they figured out how to do this, and then they contributed this to the open source community. So it's now run by the Apache Foundation, you can go to apache.org and actually download the code yourself.
Okay.
That said, there are a number of commercial distributors that also package it up for and make it a little more palatable. The three biggest ones are Cloudera, Hortonworks, and my own company, Green Plumb, that does this. This is a technology, it's very powerful, but it's in its infancy might be a little overstatement, but it's still a new technology. So compared to standard relational database technology for managing data, it doesn't have the wealth of tool sets, it doesn't have the maturity of the code set. It's still run by the Apache open source community, so anyone can go in and attempt to contribute a module, and if the committers agree that this is a good thing, it gets put in the code base, and if it's not, you can run your own version of it. That's madness, of course, but you can do that. And people do that for minor fixes. And then as people realized in this Hadoop community that writing code in the paradigm that is called MapReduce. It's very low level. I mean, it's like, my analogy is like writing assembly code. People just don't do that in the modern world anymore. They have higher level languages that are much more conducive to productivity, to programmer productivity. So a whole ecosystem developed around the basic Hadoop distributed file system and MapReduce, and they put on something that looks like traditional SQL for a latest database called Hive, and that has a lot of strengths. It makes people more productive. It's not as efficient as doing stuff really natively in a database, but it's got lots of other features that make it very useful. They've got a language called Pig, short for Pig Latin, for writing data flow. And I know people who write stuff in Pig, and they say it takes them a few hours, what would take them 3 or 4 days to write in native MapReduce. And so
but you said there's some drawbacks to that as well.
You know, everything's a balancing act here. But people say, well, you know what? When you've got a Hadoop cluster and it's running too slow, what you do is you go out, you buy another couple nodes, and you plug it in, and now you run it on more horsepower. And it's cheaper to buy nodes than programmer time. So let's be a little efficient, let's be more productive in our code generation, and if it runs a little slow, we can solve that by brute force.
So is this something where, because we're talking about clouds as well and that sort of thing, are you storing the data as well, or are you just doing the analytics?
No, Hadoop has a very interesting data storage model where they store the data generally by default in triplicate in 3 places in your cluster. They store it in 3 places both for availability, in case you don't want to store it just one place, because if you lose it, it's gone.
Yeah.
That's not good.
No.
But if you store it 3 places, then what you can do is when you have a problem and you want to analyze some data, you can run it to one of the places where it's stored. So in a big cluster, let's say, I think the biggest cluster at Yahoo now is about, say, 10,000 nodes.
Okay.
If we knew we were looking for some data, we would try and run the analysis on those nodes where the data was stored. And if we couldn't do it exactly where it was stored, we'd look on the same physical rack in the data center. So Hadoop, when it stores data, keeps track of where it's stored, and the job tracker, when it creates a job and goes out and assigns nodes, tries to assign it so that data is local to where the analysis is being done, and you're not spending time transferring data over the network to get to it. So it's storage, it's computation, it's high-level stuff, all built into it. And then there are private companies that are building tools that yet sit on top of what's already there. So there are companies like Tableau and Talon that make data analytics tools that basically sit on top of giant Hadoop and translate into pig jobs or Hive jobs or H-based jobs, if that's appropriate. That's another one of these high-level abstractions. And they go out and analyze data, and they're run through these very attractive GUI interfaces so that people can program very efficiently. And I think when relational databases came into prominence, a whole series of third-party tools evolved to fill holes and fill needs. The same thing's going to happen in the Hadoop world.
When you look at it, I mean, part of, I guess, the charm with it is being able to take large sums of data and working with them. What is a drawback with it?
What's the drawback with it?
Yeah.
Well, there are a couple drawbacks as I see them. One is that at this moment, the skill set, Hadoop skill set, is very narrow. I mean, there are not many people who can do it, and if you go out to the internet and you advertise that you've got 2 years of experience writing MapReduce code, people will come to your house the next day with buckets of money and beg you to work for them. So that's
Would you have to back that up? Because if you didn't have to back it up, I'll start posting that.
I think you have to back
okay,
it up.
Fair enough.
Yeah, pity. Otherwise, we'd all be rich
Exactly.
and famous. But the other thing is that Hadoop is not the magic bullet. There are things, and many things, and one might even argue most things, that are done much better in SQL than they are in Hadoop. So Hadoop is in the hype stage of the product acceptance curve, and everybody's got to go out and get some Hadoop. But truth be told, when they think about it rationally, they think, in a given application, some things I want to do in Hadoop, and some things I want to do in a traditional relational SQL-based world. And some things I want to do that use both components from the NoSQL, the Hadoop world, and components from the SQL world, and I want to merge them together, doing what's appropriate in which medium. So even though, I'll give you an example, in Hive is a SQL-like layer of abstraction that sits on top of MapReduce.
Okay.
So you can write SQL joins, which are what databases are exceptionally good at, but Hive isn't going to be nearly as good at it as, by an order of magnitude, as your relational database. So if you know that you've got this these series of queries that you're going to run all the time, and the data's always got to be in the same format, you're much better bringing it into a relational database, okay? Whereas other things, you're much better at leaving in Hadoop, and it takes a certain amount of experience to figure out which is which.
Well, that's where a consultant comes in.
That's where a consultant comes in.
What about costs? I mean, would it be cost effective to run both of them?
Absolutely, it would be.
It would be.
Absolutely.
Okay. Because of course you're saving time, and whatever the benefits are would outweigh the cost.
But when you do that, you have to find a way to integrate the Hadoop information with the SQL information. So Plumb, the company I work for, has got a nice nifty way of integrating things done with Hadoop with things done relationally in the database, so you can use both tools to solve an analytic problem. So, and these are going to be increasingly common as the years go on.
When you look at the companies that use Hadoop right now, the Amazons, IBMs, Intuit, that sort of thing, I mean, these are huge, huge companies with all kinds of information. Where else do you see it going after that?
Well, they're also huge companies with all kinds of information, but like the banks, the financial institutions all have this. Healthcare systems could make great use out of this. I know there are a number of institutional and political objections and obstacles to overcome, but you could imagine a medical record system that would store a lot of things in the relational information, but use Hadoop, for example, to manage and scan images, to take a look at lab reports that are coming in HL7 format and the like, and put those either in the database, keep them out, keep doctor's notes in Hadoop, translate those through OCR into ASCII text and analyze them. There are all kinds of things that you could do. I think the challenge is going to be, among other things, well, there's always the money, okay? But the challenge is going to be getting the data analysts, the people who are good at data analytics but are not subject matter experts in forestry or healthcare or medicine, even though they may know a little bit, getting them in a room together and finding a real live business problem and solving it. And doing it realistically, doing it by stages, not trying to boil the ocean and transform everything at once, but starting with something and moving on. When you get that, move on to something else. One of the great advantages of Hadoop is Hadoop has got something that's been called schema on read, as opposed to SQL, which has schema on write, which means schema on write is before you start populating the data store, the database with information, you decide how it's going to be laid out, and then you put the data in that form. If you've guessed right, or done your homework and worked right, Rob, you're in great shape. If you haven't, there are going to be questions that you want to ask that either are going to take way too long to ask because of the technology of how the data is laid out, or simply not going to be answerable at all, because the data won't be there. Whereas Hadoop tends to have data on read, which means every time you look at the data fresh, you can analyze it from a different perspective. Okay, that's the flexibility is the good side. The downside is that schema on write's much more performant because it's already compacted, it's already been analyzed, it's already been packaged and loaded in a certain way. So you pays your money, it takes your choice here, but I think you're going to start seeing this in small companies as well very soon. What's hurting is the lack of talent and the lack of high-level tools. If everyone's got to write MapReduce, we're in deep trouble. I mean, that's sort of like akin to everyone's got to write assembly code. We're not going to write in Java anymore. We're not going to write in Perl. Everyone's going to write down at machine level. Productivity is lousy. It's not transferable. That's the wrong way to go. So I think once we develop those high-level tools and people who are fluent in those high-level tools, then we will see this take off.
So the technology, I mean, in today's world, technology moves very fast. The stumbling block here is you don't have enough qualified people to work with this technology. That's going to be what slows it down. At the moment,
yeah. Though there's, do you know about the Meetup community?
No.
Oh, go to meetup.com sometime, and it's a very interesting. People can self-organize into little groups on any subject they want. I'm a member of several around Washington D.C. The data science, the Hadoop, the big data, and increasingly we see around Washington, which is a place where there's a lot of data, we see 100, 200 people come to these meetings. And people are turned away because the rooms aren't big enough for more. So increasingly more and more people are becoming aware of this, and they're learning how to do it. And I think when Java first came out, very few people could write Java, and it took a while for it to get developed and integrated into the mainstream. But when it did, it became the de facto standard, and people, you wanted to write an application, you find yourself a Java programmer.
And you expect that to be the same thing with Hadoop?
I think so, but I think what we've got to work out is which one of the high-level tools that sit on top of the base infrastructure is going to prove to be the most commonly used. So HBase is one that's in vogue now. Is HBase going to be the winner 3 years from now? I don't know. And if I knew the answer to that, I'd go out and invest in a few HBase companies and become rich.
Yeah.
But I don't know the answer to that. You know, and the Apache community will develop new stuff. You know, every week or so I hear about, oh, there's this product that sits on top of you know, the basic Apache Hadoop distribution. That does image analysis, let us say. Well, it does image analysis of a sort, but not image analysis that would allow you to, for example, extract information from full motion video and say, are there people walking across this surveillance camera, and by the way, who are they? And that technology doesn't exist yet.
Not yet.
Right, and it may not for quite some time, but you know, eventually these things will get built and they'll come into common use, and companies will be formed to distribute, maintain, improve these products, and that's how it'll work.
Okay, we'll end on a real simple question.
Right.
Where did the name Hadoop come from?
The name Hadoop came from Doug Cutting's son or daughter's pet stuffed elephant. Doug Cutting was one of the founders of people who originated Hadoop, and he needed a name for the project, and the story goes that his son had this little elephant whose name was Hadoop, and Doug wanted a name that didn't mean anything, and he liked Hadoop, so Hadoop it is.
Interesting, he picked something that doesn't mean anything then, but could mean something tremendous down the road.
Right, yeah, pretty soon everyone will be talking Hadoop, but right now, very few of us do.
Thank you very much, Marshall.
Rob,
a real
appreciate
pleasure.
it. Thanks for having me. Okay,
stay there for a sec.
Yep.
We've been chatting with Marshall Presser from Green Plumb EMC. Don't forget, you can catch his interview again in case you didn't get a chance to see the whole thing. We will be replaying it throughout the day and again tomorrow as well. This is all coming to you from the Analytics Big Cloud or Big Data and the Cloud Conference. You can catch it on websites fuselogic.tv, abctech.ca, and bestofanalytics.com. I'm your host, Rob Hislop.